Hello and welcome to the Imaging Wire Show. My name is Brian Casey. I'm managing editor of the Imaging Wire. We've got a great episode for you today. Our topic is a new alliance for agentic AI radiology reporting. So, one of the hottest use cases for AI in radiology right now is reporting, and the report is the radiologist's primary output. It's the area where AI can make a huge difference in terms of speeding up radiology workflow. But there's a number of barriers standing in the way, from proprietary data standards to closed report formats to brittle point to point integrations. So, to solve these challenges, a new coalition of radiology companies have joined forces to build a shared foundation for AI based radiology reporting. And we're really pleased to have some of these folks with us today, including Dr. Avez Rizvi of RADPAIR, Kevin Krieger of Fovea, Graham Mackay of Interlinks, and Dr. Frank Gaylord of Radiopedia. Everybody, thanks for being with us today.
Thanks for having me.
So let's do introductions. Avez, can you tell us a little bit about yourself and what you do there at RADPAIR and what RADPAIR does?
Sure. Yeah, I'm a radiologist, and I'm also the CEO and founder of RADPAIR. It's a full generative AI reporting platform that's started about 2 years and 9 months ago.
Perfect. Kevin, how about you?
Hi, I'm Kevin Krieger, the CTO over here at Fovea, and we basically have an SDK used by a lot of the large PACS workstation companies to control the viewports, and the visualization they work with on the PACS workstation. A whole lot of AI imaging, AI integration, and now with Zephyr starting into the radiology, the augmented radiology, and the agentic AI stuff.
Very good. Graham, how about you over there at Interlinks?
Yeah, so I'm CTO at Interlinks. So Interlinks is an interoperability platform interfacing between DICOM, HR7, FHIR, and making sure systems can communicate with each other.
Very good. And Frank, how about you?
So I'm a neuroradiologist by trade, but founder and CEO of Radiopedia.org, open source collaborative radiology reference, who is turning 20 next month. So 20 years of my life has been to
Awesome. Congratulations. It's amazing what you've built over there, Frank. Yeah.
Pleasure.
Congratulations. Great. So let's get started. So Avez, can you tell us a little bit give us some background about the problem here, and what are some of these challenges that we're seeing behind AI deployment and integration?
Yeah, sure. I mean, if you look at where we are today, which is the transition point really, but we have gone through this generative AI movement where, roughly, end of 22, GPT 3.5 came out and allowed these workflows where you could essentially, as a radiologist, dictate a case through RADPAIR, for instance, and generate a report just by simply talking to it like you would talk to a regular person. And we've been doing that for about 2 years and like 9 months, as I had mentioned. Where we're headed toward now is sort of this agentic AI workflow where you have a swarm of agents doing things for you. So it's not just about whether or not you can update the report, but can you ask for it to give you retrieval information? And that retrieval information can come from, for example, Radiopedia, or it could come from prior reports, or it can come from other systems that it's connected to. And you also want to be able to, for example, manipulate external systems, including the PACS. So these are all things that we're kind of going into now. And if you think about, well, what's required for that? So the model strength has improved significantly from when we started till now. So it's not necessarily having to do with what are the models capable of doing this. I kind of describe it as like, imagine you have AI, which is an airplane sitting on this runway waiting to take off. Well, how do we get there? I classically describe this as a tarmac problem. You need to have the kind of road ready between the airport and that runway so that you can actually do some of these actions. And so that's what's actually missing, is like that tarmac. And what I mean by that is, how does the AI actually know what it is you're asking for it to do? And that's a deeply technical question, and I'll try to break it down in a way that's less technical. But if you think about the standards that we have right now, and there's some incredible standards that were put out by, integrating the healthcare enterprise, the ACR, also the Radiology Society of North America, and Society of Imaging Informatics. A lot of schematic sort of standards are present. What's not present really is everything around it. So standards around workflow AI are not actually present. And what that means is like the actions you want the AI to take. So if you come out of let's say the imaging world for a second and go out to the software world, where foundation models are, you look at companies like Anthropic and OpenAI and Meta and the rest, and the way they're able to communicate with one another is because a vendor, which is Anthropic, put out a protocol. It's called Model Context Protocol. And what they said is, look, we are creating features and products that require this layer. And it allows the AI to understand what to do and the actions it needs to take. We think it's going to be useful for us. We're putting it out to the world. Maybe it's useful for the rest of you. And when they did that, what ended up happening is everybody adopted it because essentially it was useful for everybody else. So OpenAI adopted it, even competitors of theirs, adopted it because it was the right thing to do. Similarly, OpenAI, when we first started this adventure with GPT 3.5, you guys probably all know this. When you type a message, and there's like a system message and then their user message, and then what ends up happening is the result. So as you talk in ChatGPT, that's what you're doing. And that protocol of this chat-based session between a system and user message was also something that was put out by a vendor, and now it's ubiquitously used across every single foundation model company.
Mm.
The point I'm making is that in order for there to be workflow AI, vendors need to start thinking about what are the pieces that are required? How do we connect them all together? And we have to have something very similar in our space. And that's why RADPAIR took it upon themselves, because we looked around and we said, okay, well, we're already building this, much like Anthropic building MCP. We're like, well, we're going to build this for our products. Why don't we share this with the rest of the world? Because I think the field needs it. And the more people we talk to, including the people on this panel, the more we realize, yeah, this has got legs. This is something that's going to be important for imaging. And that's what the SDK is really about.
Awesome. This sounds a little bit like DICOM for PACS. Would you say this is sort of like a DICOM for AI, or is it a little bit different from that?
It's a little bit different from that in the sense that if you think about the way AI works, it is already trained in this kind of structured format. So if you look at every single foundation model company, you'll notice that they have something called structured outputs, and it's always in this schema called JSON. And JSON, it's just a way to understand for the AI on what to do based upon that schema. And every single model is base trained on that schema. But then if you kind of look into our field, you notice that we hardly use JSON for anything. We have proprietary XMLs behind closed doors within radiology reporting systems or elsewhere, or otherwise we're using text. So for us to just kind of get onto using a schema that's used pretty much throughout AI would be one way for us to standardize this. And once you do that, then the AI is able to kind of really understand what you're saying. And I guess in some ways it's similar to DICOM in the sense that once you standardize across, let's say, the DICOM header plus the pixel information, and you kind of pass that around, everybody kind of knows what's going on. So in that way, it is somewhat similar, but there's a lot of caveats to it.
Sure. So in order to get there, you're putting out a software development kit, an SDK, with the intention of creating an open standard. Can you talk about maybe a little bit of the details of that?
Yeah. So again, we think about the pieces that are necessary. So in order for the AI to understand, first, are we using a common schema? So I had talked about JSON a second ago. So that's, if the models are already trained in that, we should be utilizing JSON. So that's the first step. How do we create a canonical structure to say that, everything's in this particular schema? We understand all the elements of what a report is. So including obviously the information like the header, where all your clinical history and maybe your comparison and all that information live. What is a finding? What is a section? What are the phrases within that section? What's the order of those phrases? What's the polarity of those phrases? Are they a positive phrase, a negative phrase? A whole bunch of other stuff. You could think of that as the report document schema. So we call that the RDS. That's one component. The other part of it is the big part of it is called AEP, which is the action and events protocol. This is, think about it like all the actions you're going to take. What are those actions? It could be report edits, simple things like you say something and it ends up in the report in the right place. It could be retrieval actions, like we mentioned before, like retrieving information from different sources. It could be actions on external systems, for example, the PACS system. And so those need to be built out in a way that everybody can add and, add to this extensibility for both of these things, RDS and AEP. We're also thinking about like, okay, well, you have this canonical structure. There's going to be some part of it that you display. So we're also thinking about this other part of it called RDT with the report display template, which is like, what are you going to actually show the user? And this is where any company can kind of decide, the formatting, the how they structure the report, all that could be living in the RDT. The final component of the 4 is called their radiology ingestion pool. This is where external points of data might come in. So you might have stuff like AI classifier information that's coming from, let's say, an AI marketplace or a classifier company. You might have information that's metadata that's coming from your DICOM SR data or your risk system, wherever that is. That's a place for all that information to flow. It doesn't mean you're going to display all those things. Maybe partially you'll display some of those things and sometimes you won't. So those 4 components, the RDS, the AVP, the RDT, and the RIP are the components of the actual standard. And then you start thinking about, okay, well, how does all this get rooted together? Well, all of that lives in this thing that I call the MCP server. It's what Anthropic has put out. It's how AI can look and be essentially be rooted across and understand what needs to be done. So if you think about sort of the cookbook ingredients are sitting inside the MCP server, and then the AI is able to kind of intricately understand what it is and the actions it needs to take and where it needs to do those things. So that's sort of the full package of this the system.
Very good. Now, Avez, you mentioned that there's no AI orchestration standard existing. What kind of problems have you seen with current point-to-point integrations between different IT solutions when like versions or vendors or modalities change?
Yeah, I mean, particularly in the AI context, we have to bring it back to that because there are obviously point-to-point issues when it comes to like form fields. I'll give you one example. Let's say you have a radiology report and you have these form fields where you've intricately mapped them to, let's say, a particular piece of data. We'll take an example of an ultrasound, right? You have an ultrasound and you've mapped measurements into those form fields so that when you open a case, that DICOM SR data comes across and it fills out, let's say, the right kidneys measurements. If you were then to go and change your template or, add some new ones, what ends up happening is you have to repeat that entire field mapping all over again. And in the AI context, that doesn't matter so much, right? Because the AI will intrinsically understand that just because this template field has changed doesn't mean I don't know where to put the data because it's understanding from a contextual perspective. So if we kind of bring that back into the conversation about like, well, what does AI need to know? Well, AI needs to know, generally speaking, what is it the action you want it to take? So I think those kind of point interactions that are more difficult to do when you're not involving AI sort of get solved when you have this sort of standard in place.
That makes sense. Avez, can you give us maybe a picture of what real world examples would look like if this orchestration, this standardization were implemented in a real radiology facility?
Yeah, I mean, I'll just speak from a radiologist perspective. These kind of integrations allow the radiologist to finally serve in that conductor of the orchestra role. Like if you want to really unlock some of these sci-fi level workflows where I'm talking to the system, I'm saying, hey, there's a liver lesion I'm looking at, and it's measuring like 2.2 centimeters. And in my mind, as I'm looking at this, I'm always wondering, like, what did the previous radiologist say about this? And normally what's going to happen is I'm going to break my workflow. I'm going to go and I'm going to start looking for the report, reading that prior report, finding the section on the liver, reading it, coming back to the image, coming back to the report, and doing all this context switching. Where the reality is, I've already thought, I wonder what this radiologist said about this previous report while you're looking at the image. So just ask the question as if there was an assistant next to you. And what this will allow is, well, a retrieval from the prior report. The prior report will, the LLM will look through that, find the liver section, see that the measurement, what it was, and speak to you and basically say, well, the prior report shows that this lesion measured 1.5 centimeters. And then I can say, well, it's measuring 2 centimeters now and it's hyper enhancing. So can you add that to the report? And it just goes ahead and does it for you. That's what it sort of unlocks, is this like orchestration of the workflow, but in a more natural way, in which that you're serving more as a conductor, like I said, as opposed to doing all these sort of manual, what I consider non-value added tasks, which is like digging through data and kind of going through it yourself.
Yeah, sounds like it's really going to free up a lot of time for the radiologist. Well, let's talk a bit to Kevin Krieger at Fovea. Kevin, Fovea, you guys specialize in voice-driven PACS, navigation, and 3D. What do you think the adoption of agentic AI reporting, how would that benefit PACS and reading rooms in the real world, and what are specifically some of the benefits of this?
Sure. Yeah. So, yes, like I said at Fovea, we're all interested in how the radiologist interacts with those images and those viewports. So, what do you do with those viewports? I mean, there's great examples of, I think, as it talked about, what happened in the prior. So, load the prior images, right? Right now to load the prior images takes multiple steps, multiple mouse clicks, multiple systems, right? You're going out to your VNA, you're saying, grab that study, load it up here, choose a new hanging protocol. So, all those different things that really come from, like Yves said, a thought. What did that prior image look like, right? So, with agentic AI, if you can do all those steps and then take it and get it from a voice command, right? Because some things are quicker to give a voice event. Avez talked about the AEP, the action event protocol. So if the words load that prior and set this hanging protocol, can all happen just that quickly with just that fewer interactions, that's a huge event, right? A huge improvement. Selecting which tools, when on a typical PACS workstation right now, you right click, you open up a context menu, you go to some sub menu and you finally say, give me the linear measurement tool. Right. If instead you just say, let me measure that lesion, right? Because that's really what you thought. That was the thought in your head, right? Setting window level presets, you're navigating through some known structure, right? Show me the liver, show me the right kidney, for example, things like that. All of this can be done much more quickly sometimes with voice controls and then agentic AI to go out to the other systems. If it's something like load a prior, go to the VNA to get that data, as opposed to long sequence of mouse operations. We're not saying get rid of the mouse, right? Of course, but we're saying many things the radiologist does can be done more efficiently this way. So that's going to make the radiologist more efficient. But here's something I think is even cooler about it, right? Aveza said, you had this thought, but then you had to go do all these steps to do it, right? That takes cognitive focus, right? So if your thought can be naturally spoken and a bunch of things happen, talk to other systems, get all this stuff to happen properly, you've taken that cognitive focus of the radiologist minds out of it. And I think that really helps a lot with burnout, right? So you're cognitively focusing on the things that the radiologist adds value, interpreting the images, figuring out differential diagnosis and things like that, rather than, oh, what do I right click here? Do I left click here? Do I have to go to my VNA to get that prior or not? That type of change in cognitive focus, I think, is going to be a huge win for this. Even more than efficiency, and then you put the efficiency, the ability to remove some of that cognitive focus on menial, trivial tasks, and all of a sudden we're helping burnout, which is a huge problem.
Yeah, for sure, for sure. Now, this all sounds super powerful, and I could really see it. I can visualize in my head how this might work in the real world. But
Yeah.
do you think, Kevin, that we're going to need some safeguards around this, and what kind of checks would you want to build into the standard to make sure that it performs reliably, regardless of what kind of packs the radiologist is using?
Sure. Safeguard wise, a lot of this is you're going to be able to undo things, right? As if you ask someone to load an image, they loaded the wrong image, right? Those types of things. You want to be able to say, oh no, wrong image. Get me the 2-year prior, not the 1-year prior. Things like that can happen, right? So logging all of this and built into this protocol, built into this SDK, these protocols are logging, so you can undo things so that things are reversible, stuff like that. What do you do depending on which PACS is being used? I think there's this SDK that Yves and them have described and we started contributing to is really sort of pretty advanced capabilities, right? Some of these things are already possible. He brought up the IHE and they have an IRA and an AIRA, all these acronyms for all these different committees where they're building up some of these things using HL7 and FHIR. So the ability to go back to those if there's a PACS that doesn't support this yet, right? So that, you say you have an imaging AI result. I think Yves had talked about, getting some classification of some of the, from some imaging AI algorithm. You want to push that right into the report also, right? What happens if it's not supporting this SDK yet? You need to have fallbacks, right? So that you can get back to those kinds of HL7 and FHIR through the IHE IRA, which are great protocols and great standards. And what this protocol is trying to do on top of those, instead of like I think you had mentioned earlier, point to point, is say, okay, let's put these LLM based natural language speaking things on top of these standards that are out there that allow you to say, oh, I'm going to use a coded message to go tell the report, oh, this lung nodule was 5 millimeters, right? There's coded ways in those standards to do that communication. But what's not there is the LLM part on top of it that the radiologist can just say, oh yeah, that measurement belongs over here, or this belongs over there, or maybe the radiologist even edits that lung nodule measurement because it was incorrect. That he's probably going to do with the mouse, right? Really real fine length measurements that should automatically end up over in the report, right? So all those hookups of those things are what this SDK does beyond just the IHE standard that says here's the coded message of what you put.
Awesome. Thanks, Kevin. Graham Mackay of Interlinks. So Interlinks is a data orchestration firm. You work across PACS, EMR, RIS. Graham, can you talk a little bit about how RADPAIR's new SDK standard could reduce the amount of time it takes to onboard a new, PACS or other kind of IT installation at a radiology facility?
Yeah, so like Aves said, there's standards around DICOM, HL7, FHIR right now. There's no standard really for integrating AI into that workflow. There is the IHE profiles which are in development and coming out, but every AI vendor works differently. They all have different requirements of how the data comes in and out of their LLMs. So from an integration point of view, it makes it quite difficult. You're almost building custom interfaces for every vendor you want to integrate into. So using something like this SDK where it's standardized, you have the ability to talk to the AI vendors using the SDK, but when you're orchestrating that information and answering the calls from the AI, you're able to then use the other standards like DICOM, like HL7, like FHIR. So kind of similar to what Kevin said, it kind of sits on top of the existing profiles that are already there. It lets AI vendors focus on their core product and the AI, and then have orchestration tools like the Intelligence platform work in the other standards and work with DICOM and do the DIMSI or the DICOM web or the HR7 or the FHIR and all the intricacies and all the differences in those standards to make sure that it's simplified by the time it gets to the AI.
Where do you think some of the standards like HL7 and DICOM routing fall short today when sites are adding AI decision support, new reporting tools, things like that?
I think it's mostly around there is so many different standards to get the different types of data. So if you're looking for SR data, for example, you have to support DICOM DIMSI or DICOM REST services. If you want prior report information, you have to support HR7 or you have to support FHIR. So there's a lot of different standards that you need to support to get all the different pieces of information that you want in your models. Whereas adopting an SDK like this, you adopt one standard, and that then allows you to interface and get the DICOM information, the HL7 information, the report information, and then expands out beyond that too. And you can start looking at not just the radiology, you can start integrating in and getting stuff, information back from pathology, from labs. They talk in HL7 and FHIR, so it opens up a whole different world, even outside just the radiology, to supplement the reports for the radiologists.
And Graham, do you think that a standard like this would simplify adoption of AI, regardless of PACS or RIS or EMR?
Yeah, like you said, if the AI vendors are adopting something like this SDK, it's really easy for them to then integrate. you integrate into an orchestrator. If the AI, the PACS, the rest of the EMR adopt this SDK, great, you've got an integration point straight in right out of the box. It makes it really easy, really simple. Like the standards that are there just now, DICOM, HL7, they all have their differences. DICOM is private tags that a lot of PACS vendors use. The information you may be looking for maybe in a private tag, it's not in a standard DICOM tag, maybe in different places depending on the PACS vendor. Standardizing it into an SDK like this means you're not having to hunt for that information. You're not having to create a custom mapping for every time you want to integrate into a new vendor. It makes it out of the box. The integration's there, it's ready to go. And for the vendors that don't support the SDK, there's always the option of using an orchestrator or a middleware in between that can broker that communication for you.
Great. Very good. Very good. Thanks, Graham. So, Dr. Frank Gillard of Radiopedia. So far, we've been talking to vendors who develop IT solutions, but Radiopedia is a little bit different from the folks on the call. You guys have been doing producing reference material and guidelines, as you mentioned, for the past 20 years. How do you fit into this alliance, and kind of what's Radiopedia's role?
Well, I think the first thing to understand is how we're currently used, because that sort of explains the deficiencies, really. And most radiologists now, every radiologist will have a browser next to their PACS, behind their PACS, on a third monitor, whatever, that has Radiopedia open in a browser tab. And so if you get to the point where you need to look up a classification system or some kind of scoring system, or you just need to remember how to spell something or what the differential is, radiologists will pop out of the place that they're currently thinking about into a browser, search for that, read about it, and then go back and integrate it into their report. And that integration is pretty variable. If it's a classification system, they might need to dictate it painfully one at a time, or there might be some kind of tabular format, or they want to cut and paste, but the formatting doesn't match. And of course, the real danger, and I think for every radiologist out there, or anyone who works at a computer, is the moment you get out of the thing that you're doing is a wonderful moment to get hijacked down some interruption. And it might be, oh, I'll just check my email while I'm here. But it might also be an ad, because Radiopedia is ad supported unless you're a subscriber. An ad might grab your fancy. And then before you know it, 20 minutes later, you've purchased a new toaster, you've answered some emails, and you've forgotten what you're working about. And I think that's a real danger of how radiology currently works. And I think the idea of being able to keep in that flow not only reduces interruptions, but really is a much more pleasant way of working. Constant context switching and constantly having to fight your PACS, because there's no two ways about it. It's a hand-to-hand combat with most of these systems, because you have so many integrated pieces. You're going to the EMR, you're going to your PACS, you're going to your dictation, you're going to Radiopedia. That is exhausting. And you mentioned before burnout. I think that's a real problem at the moment. And it's only getting worse rather than better. And this is a little ray of hope, maybe, that we can reduce some of that.
Yeah, let's hope so. So how do you see Radiopedia content being used within this environment?
Well, ideally, all the acts that a radiologist currently does manually outside of their reporting environment gets folded seamlessly into the reporting environment. And whether that's calling it explicitly by a voice command saying, search Radiopedia for hemangiopericystoma, or whether it's integrated even a layer deeper than that, that when you say, apply the AST classification for X, Y, and Z, it happens in the background and pulls that information out and maybe prompts you for which measurements are required. Does this classification require axial measurements or three-plane measurements, etc.?
Yeah.
And to be able to do that without having to remember the name of the classification, without having to break your thought process and stop looking at the images, and more importantly, stop thinking about the case and the patient and the pathology and integrate all of that. We would like to be able to have our information funnel through to where it matters to patient care without all those intermediate steps.
That makes sense. No, what can be done? Guidelines change, new clinical information is researched and published. What can be done to make sure that radiologists know that the current guidance that they're looking at is the most current?
Hmm. That probably can be broadened to a society-wide question, really, because I'm old enough to remember when the internet was this great promise of, you know, verifiable, great information, free from corporate evil overlords. And largely that's the reason Radipedia was founded, on that optimistic, utopic view of the world. And now, I mean, we find ourselves in a very different place, don't we? Where so much of the internet is polluted by often AI generated misinformation or people that have various agendas. And I think a currency that is really starting to emerge as the cornerstone of some kind of pushback against this environment that we find ourselves in is trust. And trust is built on, I think, two core foundations. One is, and I hate to use the word brand, but reputation, whatever you want. Is this information coming from a group that's been around long enough that they have a track record and that you know what their motivations are, which is extremely important these days. And the second pillar is transparency. And so you need to not just have the information presented to you, but easily be able to go and see where that information has come from. And so in the case of our guidelines or articles, everything's referenced. All those references are available as links to PubMed or whichever journal article the information came from. And so anyone can quickly backtrack to find where that guideline is. And it's a massive task, as the site gets bigger and the number of classifications increase, just maintaining that is an onerous task and not something that I think a vendor who's not in this space can realistically do, nor would you want to. You might be able to set it up to get the product ready, but maintaining it is a whole other business.
Yeah. Are there certain outcomes that you think would convince skeptics that structured knowledge delivery improves patient care?
Hmm. Patient care measurement is a tricky one. Like that measuring end to end from where you interact with that tiny sliver of the patient journey at your subspecialty, and then measure that as some kind of actual endpoint, longevity, morbidity, whatever it is. That's really challenging. But I think in a resource constrained environment that we're in at the moment, and with no sign of those constraints easing in the near future, I think the biggest way to convince a skeptic is to make their life faster, easier, and more pleasant. And I think those things translate into patient outcome improvements, or at least it's extremely plausible that they do. A radiologist who is more focused, enjoying their work more, but getting through more reports so that waiting lists are lower, making fewer errors of omission or errors because they get distracted. Those must translate. And I think as a radiologist, if you show me a system that I don't need to fight against to do my job, but that actually assists me in doing that, you won't need to convince them of the outcome. It'll just be a natural extension of that.
It'll be pretty self-evident. Well, that makes sense. Frank Gaillard of Radiopedia, thanks so much. So, Avez, this all sounds really exciting, and I know that you want to show us a little bit more about what all this means. So, I guess you have a video that you're going to show us. So let's take a look at that, and then we'll jump back with some more questions.
Hey, so there's a 1.1 by 1.2 centimeter solid nodule in the right thyroid lobe. It's hypoechoic. Shoot, I forgot the rest of the criteria. Can you tell me the remainder of the criteria for adding up the score?
Still need shape, margin, echogenic foci.
Okay, so shape is taller than wide, the margin is smooth, and the echogenic foci are present in macro calcifications.
Per ACR TI RADS, this is TR5. Recommend fine needle aspiration if 1.0 centimeters, otherwise ultrasound follow-up annually for up to 5 years.
Okay, add the recommendation to the report. All right, can you read me the impression from the prior?
The impression states extensive tumor burden, significant mass effect, and subfalcine herniation.
Open the most recent relevant prior. Copy findings from prior report to current report. Okay, there's been a progression of the midline shift to 10 millimeters. And can you delete the third impression point? Okay, change the history to urinary retention. Show me liver. What's the volume of the liver?
The liver measures 1,301.63 cubic centimeters.
Add that to the report. All right, let's sign it.
Signed report.
All right, awesome. That looks really great. Well, let's open it up for questions for the entire panel. And Graham, I'd like you to maybe take this first one. How do you think the standardization of AI reporting would unlock the most value in the short term, like in the next 6 months?
So coming from a CDS background in my previous company, the software was always judged on the number of clicks that it was adding to the radiologist's workflow. Always told throughout PACS, CDS, the minimum number of clicks being added to the radiologist's workflow, so they're not being distracted from what they're doing. Something like this doesn't just remove 1 or 2 clicks, it removes a lot of clicks. Like Aves and Kevin were talking about, if you can use your voice to command the screen, bring up previous reports, manipulate the view of the images in the packs, you're almost taking away 90% of the mouse movement. So you're not adding clicks, you're actually subtracting a lot of clicks away from it and a lot of distraction from the radiologist. And I think that's one of the biggest benefits of what this SDK and the Agentic AI and reporting will bring.
Yeah, Kevin, does that sound about right to you?
Yeah, definitely. I mean, we've counted clicks for 25 years, right? Just like Graham just said, you're speaking my language when you say count clicks. So yeah, and I think that's kind of what I was trying to say earlier, that it's you're thinking and removing so much time. I mean, LLM reporting, augmented reporting is already saving the radiologist time. And then going beyond this, you can end up at, I remember forgetting that radiologist name that posted all those YouTube videos where he'd have like 6 residents getting everything ready on his workstation
yeah.
before he sat down,
Yeah.
right? Yeah, that's what Agentic AI will do. That's what this will allow you to basically have. Every radiologist will have that capability, right? Without paying for 6 residents, right? It's just so exciting.
Yeah. I saw something or heard something recently that said that during a course of a radiologist reading session, their mouse moves like over a mile, which just it
Wow.
kind of blows me away. Um, Aves, let's talk about backward compatibility. And so you're putting this SDK out there, presumably the people will write to it for new products. But what about what's already out there? I mean, how are we going to connect to all those legacy systems?
Yeah, backwards compatibility is very important. The ability to kind of uh, be able to use existing systems and then port over to this eventually is something that we've really thought about. And there are ways to do that. It just depends upon the schema and the kind of way the older reporting systems were structured. Can we port back into it? And the benefit and the beauty of this time is that LLMs are able to look at any bit of information with just a little bit of logic and very easily port right back in. And so, from a RADPAIR perspective, even though we're going to go from a completely non-proprietary way of doing things before even this SDK, we were doing things in pretty much in plain text because we didn't believe in putting in proprietary tags or using XML tags or any of that stuff. So for us, it's straightforward. to go from one way to the other. So within our system, it's going to be quite easy to kind of go between the two. I think for other groups, they need to start thinking about that. Um, but again, like I said, with the way that we've built the SDK, you could come up with an action and build it right in and say, well, this is something where you're going to get information from a proprietary XML format, and you'd like to, port it one way or the other, and you can have the system do that for you. And so there are ways for us to do that. And then we have partners, for example, like Intralinks. They can take that information from a prior, let's say, format, and because they understand our SDK, can easily translate it to the new SDK. So there are numerous ways to do it, but I think it is an important point to maintain their backwards compatibility.
Mm. So Frank, you're a diagnostic radiologist. How do you think that this world of agentic AI going out and doing tasks for you, how is it going to change your job compared to, say, when you started Radiopedia 20 years ago?
20 years ago, my hospital still didn't have PACS, so we were still on printed film. So reporting a study and trying to compare, say, the typical example was a cervical spine fracture, and you wanted to see how it looked now. Chances were that the one sheet of film that had the best view of the fracture was either still in theatre or was in the boot of the orthopedic surgeon's car and it was gone and you couldn't find it. Clinical notes were in paper that were locked in the basement that you couldn't get to. So already we've seen this tremendous shift towards being able to access so much more of the patient's information, other modalities, other tests. And this really takes it one step further, but undoes the negative side of all that access to that information, which is currently it eats up your time to find that information. When I first started, you'd look in the bag, and if the sheet wasn't there, you'd move on. There was no recourse to looking for it somewhere else. Currently, in our hospital, we have our own EMR, we have our own PACS, but we're also linked to a network of hospitals nearby, each with their own PACS and their own EMR. And so you need to know where the patient's journey might have taken them. You can smell out sort of, oh, I bet they've had a scan at this place because it's the cancer center, so let me have a look there. And then you can't find the pathology in your EMR, but you happen to know that the private hospital down the road isn't integrated, but you have a login for that one. So you go and have a look there. That takes time. It provides better patient outcomes or care anyway, because my report then integrates all that information, which is, I think, the core of what radiologists should be doing. We shouldn't be describing machines, and we shouldn't be, information retrieval gophers. We should be taking it all in and integrating it into a conclusion that helps clinicians and patients move forward.
That's a
And
great
I
point.
think this kind of agentic way of retrieval of information through a system that is heterogeneous and complicated with historical quirks, and to be able to have a system that does this fairly naturally and quickly for me would make a tremendous step towards me regaining my focus towards what my core value add competence is, which is understanding the whole of the patient and integrating that.
Those are great points. Great points. So, Aves, our time is drawn to a close. What advice would you have for vendors and health systems, and maybe even radiologists that want to join the coalition?
Yeah. My strongest point here is that the places that we want to compete are going to be on products and features and bringing more excellent ways of working to radiologists. That's been the core mission and vision of RADPAIR, is to allow the radiologists to do their jobs and do it effectively and do it ultimately with joy. We always say we want to bring the joy back to reporting. And so on this foundation base layer, this is not where I want to compete. RADPAIR does not want to compete on the exoskeleton and how do we move data packets around, right? This is something that I think everybody should agree that should be given freely to the imaging field, and should be something that all of us agree can make us better, which is why I've reached out to even our competitors. I've reached out to standards committees, and we want every vendor to come join us on this journey. this isn't about any one company. This is about, all the folks that are behind it who are saying, let's work on this together and ensure that we deliver better care for our patients. So that's why I'm super excited about this. Thank you very much for all the panelists that are here, Frank, Graham, Kevin. It's been fantastic. I think as we grow this coalition, as more people hear about what we're doing, and there's going to be obviously the announcement today, but you're going to see more and more people join this coalition, and hopefully by the time you see us at RSNA, it'll have grown even further, and we'll have started a pretty nice movement together.
Awesome. Well, it's going to be great to see it grow. Well, I'd like to thank Dr. Avez Rizvi of RADPAIR, Kevin Krieger of Fovea, Graham Mackay of Interlinks, and Dr. Frank Gaylord of Radiopedia. Gentlemen, thank you all so much for being with us today.
Leslie, thank you
Thank
for
you.
having me.
Signing off for the Imaging Wire, my name is Brian Casey.